biomass gasification process is based on Kirko's technology and has been improved over 10 years of research and development in Spain. The process begins after receiving the biomass and converting it to homogeneous fuel. An automated process receives the biomass and dries it in a patent tin deep bed drying system. Once prepared in size and moisture, the biomass is transported and fed into the gasification system, which is the heart of the plant. In the bubbling fluidized bed reactor, biomass aerocatalysts react, generating more than 40 major thermochemical reactions with an homogenized reducing environment and controlled temperature and pressure conditions. This process produces a gas called synthesis gas, or syngas. The syngas exits the reactor at 800 degrees Celsius and must be conditioned before being used in combustion engines. The syngas conditioning system consists of two fundamental stages. The first stage consists of high-efficiency cyclones, which separate the solid particles of char and ash. In the second stage, the syngas is subsequently cooled and cleaned, ensuring optimum conditions for energy use in cogeneration systems. Fueled by the syngas, the cogeneration module is a generator that produces energy, which is fed into the grid. Moreover, these internal combustion engines produce useful heat at two temperature levels, thus increasing the added value of available heat. The cogeneration modules are developed by GE Genbacher, a company that has vast and proven experience in cogeneration with special gases such as syngas, with references of more than 40 megawatt in gasification applications. NASA's technology is also possible to substitute fossil fuels for renewable energy in direct thermal applications. Syngas is burnt directly in thermal units such as gas boilers, dryers and ceramic kilns. The entire process of obtaining biomass and its subsequent gasification has a minimal environmental impact, meeting all the EU's current regulations. It's a clean, ecological and sustainable process. NASA and Kirko have strived to update and improve both the gasification and gas cleaning technologies over the past recent years. NASA specializes in the design, manufacture, installation and commissioning of power plants in the 1 to 6 megawatt range using GE Genbacher engines. Has the most advanced gasification technology in Europe in full commercial operation, generating both electrical energy and fossil fuel substitution in thermal processes, and thus achieving sustainable green energy production.
This is Alan of this video. After watching these two videos, we know the large steel and large steel systems. You may ask the question, how to develop new technology to create a new system? It's very important. Actually, for the development, for the scale up of different technologies and systems, usually it's not easy. At the beginning, it is an idea. All the new ideas actually is generated from the university and the research institute. Of course, some of new ideas also generated from the research department in some companies. So the first important thing is that before you develop a technology, you should have a new idea. We also call it innovation. Innovation is one of the most important part in the development of different technologies. How to understand the innovation? Anybody can give us give us your understanding on how to understand innovation from your opinion. What's innovation? Do you have any ideas? Innovation. 创新啊，大家创新是什么？ Do you have any? What's the
To build something that exists before, like an idea or production or industrial line or anything, just to build something that don't exist before.
Something new, is it? Okay. Build something new. That is innovation. What's your opinion?
Maybe accept the building the new idea or like materials. Maybe improve the nowadays the improve the ideas of others. Maybe also the innovation.
Okay. Actually, your opinion is very it's correct. I also agree with you. Actually, innovation is very important. From this slide, we can see idea is if it is from 0 to 1. Sometimes we call it as original innovation. It means that it is a very new things. It is different from traditional principles. Nobody has the idea about that. You create it. It is original innovation. The second student answer is also correct because sometimes it's very difficult to develop original innovation from 0 to 1. It's very difficult. But what we can do is that we can improve. Yeah, we can improve the performance or structure or materials based on the existing things. That is secondary innovation. Both of these two innovations actually are also very important. But for the development of technology, it will go through 9 steps from TRI1. The full name of TRI is Technology Readiness Level. This TRI actually is to evaluate the maturity of your technology. If your technology is very mature, you can use that in the practice. It should reach TRI9. If it is just in the lab scale, sometimes it should be in these areas. So now let us go through these levels to see what's the difference. TRI1, it is the basic principles observed and reported. From this part, actually, we only have an idea on the principle of your technology. TRI2 is technology concept and application formulated. In this part, actually, we only have some technology concept in mind. Sometimes, actually, we didn't do any experiments to verify whether your technology is good or not. We didn't do that. It is also at the concept level. Well, for the TRL3, this part, we have to do some experiments and we have to do some analysis for your technology to verify that your technology is workable in the lab. For the TRL4, it is component or breadboard validity, and TRL5 is component and breadboard validation in relevant environment. In this part, actually, after we develop the technology, sometimes it's not sufficient. We also should have some components in your technology. For example, if you develop gasification technology, or you know the principle of gasification, but you should have a reactor system. Reactor system to, but maybe it's not a full system. It's a component in the system. For example, the body of the system you have some design on that. You can use that in the lab, something like that. It is level 4 and level 5. But for the level 6 and the level 7, you should build up a prototype. It means that you should have a system. For example, for the gasification process, we can see some lab scale system. The treatment capacity could be about 10 kilogram. For that system, actually it is at a level 4, level 5 and a level 6, because that system has been used outside. Sometimes we have used that in our campus. We also use that system in some other farms. It is the use of reactor prototype in relevant environment. So after level 6, it is level 7. Level 7, it is system prototype demonstration in a space environment. It means that we have to use your system in the right places to handle the real waste on site. Even so, the system is in a small size. Now, for the level 8, it is actual system completed and flight qualified through test and demonstration. In this part, actually, we should have a full set of your systems. And you also need to use the real waste to do the test. If this process is working well, okay, your system can reach level 8. But for our university and research institute, generally, we can get level 6 or level 7. Because if you want to jump to level 8, you need the enough money to develop your system. Sometimes we don't have that. That's why usually we will collaborate with some other companies. We will be focusing on the technology part, and the company will focus on the use of this technology in the market. That is level 8. The highest level is level 9. Level 9, actually, it is an active system right through successful mission operations. If your system can reach this level, it means that you can use that in the market. But before we use the technology in the market, sometimes we need to solve a lot of issues. In the lab, we can solve the issues of technology. But for the pellet scale systems, we should solve some engineering issues. Once the system actually reach the level of 9, we should solve all the issues, including engineering issues, also safety issues. For example, gasification process, actually, it is a thermal conversion process. When we do the test in the lab, it is fine. When we use a small scale system, it is fine. Don't have a lot of safety issues. But if you use large scale, safety issues is also very important. On the other hand, actually cost is also very important. If your system is very expensive, it means that it's hard to find the market. So all this, if you can solve all these issues, okay, you can use your technology in the market. This is a scale up of all different types of technologies in the practice. You can see it is not easy. It is not easy. But one of the most important part is for the level 1, and from level 1 to level 7. all these parts actually are finished in the research institute and university. So you can contribute a lot for these levels. Part 3 is a biomass pyrolysis process. Biomass pyrolysis